Oh, this is Daniel Raymond, the voice behind Ray's Guide. A longtime subscriber asked that I dig into Chris Roberts' post comment where he discussed the database troubles with Star Citizen and what I thought about the comment. I am going to presume that you have already read that comment or listened to any of the great number of other content creators who have covered what is essentially a letter from the chairman about the rocky recent releases. Essentially, Chris deflected most of the problems onto the decision to implement the Entity Graph database and the unnamed third-party vendor that they are using for the Entity Graph database. So let's start with one thing. Unless you are a database company, nobody builds their own database. There are decades of research and patents that have gone into these. You are not going to be able to build a better mousetrap by creating your own database. Now let's look at what CIG started with, a SQL Relational Database. SQL, or Structural Query Language, is a standard set of commands for accessing and manipulating data. It makes it easy to switch from one relational database to another, both in terms of actual code and programmer knowledge. Relational database structures data in tables like a spreadsheet. Each item is a row and each property is a column. So let's say you have a table of all the spaceships in the universe. One column might be the model of engine in the ship. You can then create a table of engine models where each engine you can give its characteristics. You can then join the tables on that field so that you can create a view or query where you see all the ships and the capabilities of their engines without having to have all that data duplicated over and over again for each ship. You can also change all the engine properties and all the ships just by changing the engines table. Now, seemingly small changes in features can have huge impact on the database. So let's say you decide that you want to have individual damage states on the engines and to have the engines be able to exist outside the ships. There are some other ways of doing it, but the most direct way is that we now have a table of every single engine in the universe by serial number, where its location is, damage state, etc. is stored, and then a link by model number to the standard features of that model of the engine. Now you have two joins and a big table of every single engine in the verse, which logically would be larger even than the table of every ship in the universe. Now, component-level damage and component-level replacement and salvage are cool features, but the point is that a cool feature can have huge data impact. And that's just engines, not all the other components, etc., and hulls, whatever. Now, CIG started with a SQL relational database because graph databases were not yet mature. Graph databases view the data in an entirely different manner, and thus switching from relational to a graph database is huge. You have to put your mind on in a whole different direction. The reason is that in a relational database, the connection between items is secondary data. It is defined by the way the tables are joined. In a graph database, the linkages are primary data. The ship object is linked to the engine object, which is linked to the engine object model. In many ways, this was databases catching up to the object-oriented model and object-oriented programming, which programming had been moved to some time ago. So if you're dealing with data that is easily handled in a tabular manner, for example, e-commerce, then absolutely SQL relational databases are the way to go. Just because they have been around for decades doesn't mean that they are obsolete for appropriate uses. But when modeling complex and messy realities, a graph database means that you are storing the data much closer to the way you are actually modeling the data and much closer to how you are processing the data. And thus, it will hopefully be both easier and more efficient. Hopefully, you are being able to save layers upon layers of joins on an expanding sea of tables. But not because this being a new tech that graph databases are higher performance than relational. Decades of R&D have gone into making relational databases high performance. So let's talk about what, to a database engineer, constitutes an enterprise-class database. There are two qualities. The first is robustness. This is measured by something called the acid test: atomicity, consistency, isolation, and durability. This makes a database rock solid, no matter what might happen. If a database can't pass one of those criteria, not only won't it be considered enterprise class, it won't be considered a serious database at all. Performance is the second characteristic of an enterprise class database, but it is second. The evaluation is robust first, and then is the performance sufficient. Now, robustness uses the acid test. Performance is measured by throughput, latency, and scale. Throughput is the number of changes that can be processed in a second, also called transactions per second. Latency is the time it takes to complete a transaction in milliseconds. You might think that the throughput and latencies were the inverse of each other, but most databases are designed to process multiple transactions at once. Scale means that the results don't fall off fast as the database gets huge. Now, while the robustness criteria are binary, the database either is or isn't, the criteria for performance are qualitative. There is not, nor will there ever be, a database that can handle infinite transactions instantaneously or on an infinitely large database. Moreover, bottom line, you can't solve every problem by simply writing a larger check to Amazon Web Services. There isn't infinite money either. Now, all three things that define database performance, throughput, latency, and scale, are all needed for an MMO, but particularly the demands on an MMO for latency are far beyond the typical enterprise-y things that enterprises do with an enterprise database. So, for example, if it takes a full second for Amazon to process your Buy Now button, that's fine. But if it takes a full second for the game to record that your shot scored a critical hit on the engine and the engine is destroyed and the ship is disabled, that is impossible lag. So sometimes the game has to fudge and report that the hit was a success before being able to validate with the database that the record of the success was saved. But the real question is what expands faster: the efficiency of database technology, the declining price of database processing power, or the ambition to create ever more database-crushing features. And as we know, this project is anything but ambitious. So, example, recently there was some offhanded comments from CIG about bullet-level manipulations. Presumably, this means that you can find an individual bullet on the ground left some time ago, pick it up, and use it into a magazine or gun. But what it also means is that essentially now every single bullet in the verse has its own data record. Now, if they're doing this for Squadron 42, how many bullets are in the game universe at any time? Maybe 1,000. Now, how many bullets are there in the entire PU verse for Shard with full persistence? Very likely millions. Yes, on certain occasions, bullet-level manipulations might feel cool, but is it worth it on an entity graph that is already straining? Questionable. That's why I've been repeating something often. Don't presume that everything that works in Squadron 42 should be presumed to be a good idea for the persistent universe, mostly for gameplay reasons, but also for database load. And Chris, in his comments, certainly made it clear that people were going to be shifting from perfecting things in Squadron to migrating them to the persistent universe. Now, when it comes to purely quality of life things, sure, great, but each thing needs to be given that critical analysis. What are the strains and balance issues of moving it to scale in the persistent universe? Which brings me to the thing that really caught my attention. It wasn't actually the database stuff. It was Chris Roberts saying, quote, "We've now hit an inflection point in Squadron 42's development that allows us to start bringing this work into Star Citizen in the near future," end quote. The thing is, in agile development, there aren't many things that are supposed to feel like inflection points. Teams pick up an item from the queue, work on a sprint on it for a month or so with daily check-ins on progress, and then pick up the next item from the queue. The sense of steady effort is the whole point. The only way an inflection is hit is if the nature of what is in the queue changes, if it is no longer new features, but fixing and tuning. The point of becoming feature complete is a traditional dividing line between alpha testing and beta testing, and would indeed open up the door to cross-migration because you no longer have to go back and revisit it if it changes in Squadron 42. But that doesn't mean it can or should move to the PU as is. Still, if Squadron is approved as feature complete, it is indeed a big deal. And now for an update on our giveaways. The Hull C giveaway is complete. Congratulations, Mark Booser. We now have our IAE Week ship giveaway for the winner's choice of either the Galaxy Complete, the Master Martial Mighty Moving Medical Machine, or the brand new Big Box Bargain Bazaar, a.k.a. the Merchantman, or $100 of Steam Store credit. Just be a member and be entered automatically, or subscribe and comment, including the secret word. And the secret word for this video is the test of whether a database system is robust. Fly safe, keep it real, and I'll see you in the verse. This is Daniel Raymond for Ray's Guide.